Hello and welcome to my YouTube channel ChemWis. In this video we are going to learn an important name reaction, that is the Ley-Griffith Oxidation. In this reaction, a primary or secondary alcohol in the presence of tetrapropylammonium perruthenate catalyst and N-methylmorpholine oxide as oxidant in DCM or acetonitrile solvent in the presence of molecular sieve at room temperature gets oxidized to aldehyde or ketone. Mechanism of Ley-Griffith oxidation. Perruthenate ion has very electron deficient ruthenium atom due to +7 oxidation state. Alcohol has electron-rich oxygen atom. So, attack of alcoholic oxygen on ruthenium of perruthenate gives this adduct, which undergoes intramolecular proton transfer and electronic delocalization like this to produce this pentavalent ruthenium compound and aldehyde or ketone. The pentavalent ruthenium compound then removes water molecule to produce RuO3-. The water molecule thus produced gets absorbed by molecular sieves. Now N-methylmorpholine oxide comes into picture. The oxide of N-methylmorpholine oxide attacks on ruthenium atom of RuO3- to produce this adduct, which removes N-methylmorpholine to regenerate perruthenate ion. This cycle continues till the reaction gets completed. Now let's have few examples. This is a piperidine derivative with primary alcohol group. When it is oxidized under Ley-Griffith oxidation condition, produces corresponding aldehyde. Another example, it is also has primary alcohol. So when it is oxidized under Ley-Griffith condition, produces aldehyde. This is a secondary alcohol. So when it is oxidized under Ley-Griffith condition, produces corresponding ketone. That's all in this video. Please subscribe my channel and press the bell icon if you like this video. Thank you very much for watching this video.